also be called a BMS, or the battery management system. Now I'm going to show you how to set it up. It's got some tabs there that we're going to do some soldering. Now I'll go through the schematics of each of these points and what they connect up to. But first, these are a cheap board. You can pick them up on eBay for a few dollars. Now you can also add a switch to turn the unit on and off if you need to, and also a plug-in type of connector if you want to charge that way for the actual charger. They aren't necessary, but I find it's a little bit easier and makes it easier if it's mobile and stuff like that. Now I also have these battery holders as well for the 18650 batteries, because this board will only take 18650 batteries. Now if we go through the stats of this board, you can see the dimensions there. The maximum discharge is 10 amps. The overcharge and the over discharge detection voltages are talking about the cells, because the cells will go from that 3.7 volts or up and down depending on how much it's charged or how much it's discharged. As you can see down below, suitable for, you can see that it's 12.6 volts at full charge, and the nominal voltage would be at 11.1. So you can see the other stats there. Now what I'm going to jump onto is the wiring. So pretty straightforward. We have the B plus that goes to the positive of the first battery. It then goes from the negative of battery 1 to the positive of battery 2, the negative of battery 2 to the positive of battery 3, and then you'll find that it'll go from the negative of that last battery down to battery minus, or B minus as it's written on the actual board. Now what that does is it creates all three batteries in series, and that's why it's called 3S, because there's three batteries in series. Now each of the 3.7 volts will add up, adding to that 11.1 or 12.7 if you look at the maximum charge of the lithium ion. Now where you connect the B1 and B2 into the middle of those battery connections, the reason for that is for balancing and to keep all of the actual cells balanced properly, which is the main reason you have this board itself, because when you're charging and discharging, you want to make sure that you get the life out of it and that it's actually working properly. Now the only thing that's left is the P plus and the P minus, which is your positive and negative connections. Now that's how you charge and also how you discharge when you're actually using the batteries. So you can see here that I've actually wired up, so from the B plus through to my first battery, and where I've gone from the negative of that holder, I've then connected the positive for the next one to the B2. So I've wired it up the exact same as the wiring diagram required. The only difference is I'm using the battery holders, connecting the wires together instead. And I've also soldered them on the back of the board. It's a bit harder on the front side because there's tabs there which are designed for a spot welder to add the actual tabs, which I can show in another video. I'll get a spot welder and do something similar. So it was easier for me to solder it onto the back. Now as for the batteries, I have 3 of these 18650 cells. Now when I tested each of the cells, they are very close to each other. They're only about 2 milliamp hour out from each other. Now we want to get those cells as close as possible, reason being because of balancing, especially with this charger, as it's trying to balance the cells. If they're too far out, we're going to have issues in balancing and also the capacity of the overall battery. So we want to make sure they're similar, and we want to make sure that they're all charged up fully. That way when we plug them into the cell holders, you're actually creating that circuit. You don't want one to be severely undercharged where the others are overcharged or fully charged. By measuring each of the cells, you can see there's 4.14 or roughly around that same amount. All right, so the final setup, we have our plug, which then positive, negative into the board. We have the first battery into that first one, which then wires back across to that B2, which goes into the second battery, and then from the second into the third battery and then back to the negative on the board. Now, if I leave the prong from the multimeter into the negative side of the third battery and I put the positive into the positive side of the first battery, we can then look at the multimeter and see the voltage, which gives us 12.3 or 12.4, which is our 12 volt battery. Now, if I check across two cells, it's 8.25, and if I check across the one, we get the 4.1. So it adds up the 4.1 times by 3, etc. Now, that gives us our 12.4 volts. Now, something with this charger as well, I want to point out, a normal 12 volt power supply charger, as you can see here, has an output 12 volts. Now, the actual charger for these battery circuits need to be a little bit higher than 12 volts so it can actually charge the battery pack. And this is one of them here, which you can see it's actually quite zoomed in because it's a small charger, but AC adapter for lithium ion battery, and its input is between 110 and 240 volts AC, and then the 12.6 DC out. So not only is the voltage a little bit higher to charge the battery pack, but for these charging or units, these actual circuit boards, if you don't actually charge it fully to begin with on that first run, you won't actually get an output from the board itself. So you need to do that and give it a full charge before you'll actually get an output on the circuit. So as you can see, I've charged it up. Now I've got 12.44 volts actually outputting on the terminals. Now I'm just showing you here, you can set up the batteries in different ways. I set it up this way for the application I was using it for, but if you wanted to, you could put the three batteries next to each other like this, and you could get a bit of a smaller pack all together. They wouldn't necessarily be as wide. Now you could also run them lengthwise and have all three of the batteries running right next to each other like I've set up here. And you could put the circuit right up against one of those batteries. So it could be a nice thin, longer type of battery pack. It just depends on how you want to set it up. All right, so that's how we make a